Is about the vector identities class 2. Previous in that vector identities class we completed 3 theorems. Next fourth one that is prove that curl grad pi is equal to prove that curl grad pi equal to 0. Prove that curl grad pi equal to 0. Proof, let pi be any scalar point function pi be any scalar point function, and grad pi is equal to, what is grad pi value? Grad pi is equal to I bar into dou pi by dou x plus j bar into dou pi by dou y plus k bar into dou pi by dou z. This is grad pi value. Next we have to show that curl grad pi equal to 0. Curl grad pi is equal to del cross del pi. What is del cross del pi value? Mod I bar j bar k bar dou by dou x, del coefficients of I j k are dou by dou x, dou by dou y, dou by dou z. Next del pi coefficients of I j k are dou pi by dou x, dou pi by dou y, dou pi by dou z. Expand the determinant, we get I bar into, this is dou by dou y of dou pi by dou z. What is that? Dou square pi by dou y dou z minus dou square pi by dou y dou z or dou z dou y minus j bar into dou square pi by dou x dou z minus dou square pi by dou x dou z dou x or dou z dou x plus k bar into dou square pi by dou x dou y minus dou square pi by dou y dou x. Okay, all the terms are cancelled, that is equal to 0. Since curl grad pi equal to 0, therefore note is curl grad pi equal to 0, curl grad pi equal to 0. We have grad pi is always irrotational vector. We have grad pi is always an irrotational vector, If curl f bar is equal to 0, then f bar is said to be an irrotational vector. Here curl grad pi equal to 0, therefore grad pi is always an irrotational vector. Next prove that divergence of curl f bar is equal to 0. Prove that divergence of curl f bar is equal to 0. What is the curl f bar value? Let a proof is let f bar is equal to f1 into I bar plus f2 into j bar plus f3 into k bar be a vector function, then curl f bar is equal to, first we can find curl f bar. Curl f bar is equal to del cross f bar, that is equal to mod I bar j bar k bar dou by dou x plus dou by dou y plus dou by dou z, dou by dou x, dou by dou y, dou by dou z. X f bar coefficients of I j k are f1, f2, f3. The expand this determinant, we get I bar into dou f3 by dou y minus dou f2 by dou z minus j bar into dou f3 by dou x minus dou f1 by dou z plus k bar into dou f2 by dou x minus dou f1 by dou y. This is curl f bar value. Next, prove the divergence of curl f bar. Divergence of curl f bar is nothing but LHS values. Divergence of curl f bar is equal to del dot curl f bar. Del dot curl f bar. What is del value? I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. This is, we can apply the vector dot product, we get dou by dou x of the first term is dou f3 by dou y minus dou f2 by dou z minus dou by dou y of j bar dot j bar is 1, dou by dou y of dou f3 by dou x minus dou f1 by dou z plus k bar into dou by dou z of no k bar, dou by dou z of, because k bar dot k bar value is 1, dou by dou z of dou f2 by dou x minus dou f1 by dou y. Simplify this, we get dou by dou x of, that is nothing but dou square f3 by dou x dou y minus dou square f2 by dou x dou z minus dou square f3 by dou y dou x minus of minus plus dou square f1 by dou y dou z plus this is plus dou square f2 by dou z dou x minus dou square f1 by dou z dou y, that is equal to, simplify this, we get all the terms are 0. This value and this value, x z, all the terms are cancelled, therefore it is 0. Therefore, since divergence of curl f bar equal to 0, divergence of curl f bar is equal to 0, therefore curl f bar is always, therefore curl f bar is always solenoidal vector. Curl f bar is equal to, divergence of curl f bar is equal to 0, then f bar is solenoidal vector. Next theorem is, prove that if f comma g are two scalar point functions, if f comma g are two scalar point functions, then prove that divergence of f del g is equal to f into del square g plus del f dot del g. First find del g value. A solution, a proof, given f comma g are two scalar point functions, first find del g is equal to I bar into dou z by dou x plus j bar into dou z by dou y plus k bar into dou z by dou z. This is del z value. Then f del z value is what? F into del z is equal to I bar into f into dou z by dou x plus j bar into f into dou z by dou y plus k bar into f into dou z by dou z. Multiply with each term with f into dou I bar into f into dou z by dou x plus j bar into f into dou z by dou y plus k bar into f into dou z by dou z. Then go to the question. LHS value is what? LHS is prove that divergence of f into del z. This is LHS value. Divergence of f into del z equal to f into del square g plus del f dot del g. Divergence is nothing but del dot f into del g. What is f into del z value? Del value is I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. Dot f del g value is I bar into f into dou z by dou x plus j bar into f into dou z by dou y plus k bar into f into dou z by dou z. Apply the vector dot product. I dot I is 1. Get dou by dou x of f into dou z by dou x. Next j bar dot j bar is 1. Dou by dou y of f into dou z by dou y plus dou by dou z of f into dou z by dou z. Apply the UV differentiation. Differentiate partially with respect to x. This is u, this is v. UV derivative u into v dash. F into dou by dou x of dou g by dou x is dou square g by dou x square plus dou g by dou x is constant, dou g by dou x into u dash is dou f by dou x is the first term plus this is also UV differentiation, u into v dash plus v into u dash. F into dou by dou y of dou g by dou y is dou square g by dou y square plus dou g by dou y into dou f by dou y, u into v dash plus v into u dash plus this one also uv. Apply that uv derivative formula. F into dou square g by dou z square plus dou g by dou z into dou f by dou z. Differentiate partially with respect to z. Here f into dou square g by dou x square, here f into dou square g by dou y square, next f into dou square g by dou z square. Here in this f common, can write dou square g by dou x square plus dou square g by dou y square plus dou square g by dou z square plus remaining terms are dou f by dou x into dou z by dou x plus dou f by dou y into dou z by dou y plus dou f by dou z into dou z by dou z. Next this can be written as f into, this is f into del square g plus this can be written as I bar into dou f by dou x plus j bar into dou f by dou y plus k bar into dou f by dou z dou f plus dot I bar into dou z by dou x plus j bar into dou z by dou y plus k bar into dou z by dou z. We can apply the vector dot product. I dot I is 1. We get first term is dou f by dou x into dou z by dou x. Next j bar dot j bar is 1. Dou f by dou y, dou f by dou y into dou z by dou y. Next third term is k bar dot k bar 1. Dou f by dou z into dou z by dou z. We get this one only, that is equal to f into del square z plus this value can be written as del f dot del g, that is equal to RHS. If f comma g are two scalar point functions, if f comma g are two scalar point functions, then prove that divergence of f del g is equal to f into del square g plus del f dot del g. If f comma g are two scalar point functions, then first write del g value, multiply with f. Next go to the given question, divergence of f del g is equal to del dot f into del g. The del value I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. Apply the vector dot product and simplify that uv derivative formula, then we get the solution is given answer is f into del square g plus del f dot del z. Here in this class we discussed about the three topics, that is three questions. Prove that curl grad pi equal to 0. Curl grad pi equal to 0, first write grad pi value, then find curl grad pi. It is equal to 0. Curl grad pi equal to 0, we have grad pi is always an irrotational vector. Next, second one is prove that divergence of curl f bar equal to 0. First define curl f bar value, then apply the divergence. Divergence is nothing but divergence of curl f bar equal to del dot curl f bar. Simplify that, we get 0. Therefore, notice divergence of curl f bar equal to 0. Therefore, curl f bar is a solenoidal vector. Curl f bar is solenoidal vector.